Alrighty, we got two proof-oriented triangle theorems here today. So I have a feeling we may be doing some proofs. Alrighty, the no choice theorem. Oh my goodness. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Let's just talk this one out, shall we? Have a nice little math convo, if you will. So say I've got this triangle here, and you know what? These don't even have to look congruent. It's okay, one could be bigger than the other one. We'll talk more about that later. D, E, and F. Alright, let's say that A is congruent to D, and let's say that C is congruent to F. What do you think must be true about angle B and angle E? Well, if your guess is that they have to be congruent, then you are absolutely correct. We have no choice but for those to be congruent. Let's think about it. Let's say that angle A is 60 degrees. That would make angle D 60 degrees, yay? Let's say that angle C is 50 degrees. That would make angle B 50 degrees. So what does angle B have, or sorry, angle F, my bad, was 50 degrees. So what does angle B have to be in this triangle over here on the left? Well, we got 110 degrees, so that makes this 70 degrees, right? Doesn't look like it, but it's okay, we'll live with it. That makes that 70, so it adds up to 180. And let's go with the same logic over here. 110, subtract that from 180, I get 70. Oh my goodness. These two angles are indeed the same measure. Holy cow, holy guacamole, if you will. That, my friends, is the no choice theorem. If you got two pairs of angles congruent, the third pair has to be congruent. You have no choice. Why don't we try a lovely proof with this? All right, so I've got angle A congruent to angle X. I've got angle AVZ congruent to angle XYB. Cool. And I have ZVB. We'll do 2 for that. And ZYB or BYZ. Whoop. Those guys are congruent. And I want to prove that it's a parallelogram. Okie dokie. Wonderful. And that parallelogram that we're trying to prove is VBYZ. It's that guy that's inside. So if I remember ways to prove parallelograms, one of them is opposite angles congruent. And I've already got one pair of opposite angles congruent. So if there was a way to prove this guy congruent to that guy, we'd be in good shape. Well, if I'm not mistaken, the no choice theorem would tell me that angle AZV, this guy right here, and angle XBY, oops, I should probably use the same congruent mark, yeah? Boom. Those two angles are congruent by the no choice theorem. All right. Now, got a couple options. I'm going to call this guy angle 1 and angle 2 right here. Make it a little easier. If I were to state that angle 1 is supplementary to angle AZV and angle 2 is supplementary to angle XBY, then I could say that subset congruent angles are congruent. Am I wrong? I am not wrong. I am right. We could do that and then boom, we got ourselves a parallelogram. Or some of you may have thought, oh, well, AZY and VBX are straight angles, and all straight angles are congruent, and then you can use subtraction property. Absolutely a wonderful possibility. I'm going to go, that was terrible. I can't believe this stuff is moving on me. I'm going to go the route that I first described, as it'll be one step quicker. Okay, let's see if I can now move. There we go. Grouped them all together. Okay, cool. Let's write it up. So my first one would be angle, given, and then angle AZV, and we could have numbered that one as well, I just didn't, and angle XBY are congruent. That'd be the no choice theorem, NCT, or write it out, I don't care. Up to you. This is America. Freedom. Rock and roll. All right. So now I've got angle 1 is sup to angle AZV, and angle 2 is sup to angle XBY. Def sup. I do want to establish that they are supplementary before I use the fact that they are supplementary. So it's good to jot that down in our proof. So angle 1 is congruent to angle 2. Sups of congruent angles are congruent. And then lastly, parallelogram V, B, Y, Z. My reason? Opposite angles congruent, then parallelogram. Woo-woo! Heck yeah. That wasn't too bad. That was quite enjoyable, if you ask me. Well, this looks like a wonderful amount of fun here. We got a circle with O being the center. What do we know about circles? Radii are congruent, right? Heck yeah, we do. Angle SOV is congruent to angle TOW. Oh man, these things overlap. SOV, sometimes my marker doesn't respond. It's wonderful. And TOW are congruent. Cool. Then we have WSO and VTO are congruent. And I want to prove that W and V are congruent. Well, let's think about our no choice theorem. If I could get angle WOS congruent to angle VOT, then the no choice theorem would get these two congruent. That sounds wonderful. Can I do that? What if we were to subtract out this angle? What would be left? Two congruent angles. And then I got my no choice theorem to finish this bad boy out. I think we're ready to rock and roll. That wasn't too bad at all. So I've got my given. I've got angle WOS is congruent to angle VOT. Subtraction. And then I've got my proof. W congruent to angle V. No choice theorem. Wonderful. Now I'm going to lay a hint on you guys, a subtle hint. On your test and on your quiz, you will have one proof, and you will have no choice but to complete this proof. Okay? No choice but to do that proof. Hopefully, that wasn't too subtle.